How are you, everybody who is watching this video? I would like to take this opportunity to welcome you into Workshop 7, where we're going to discuss very important transmitter module in telecommunications or in electronics communication laboratory. My name is OLENJOLAI. The first time to meet me, I would like to welcome you into these interesting moments of learning about applications of electronics. We are in departments of telecommunication engineering, where actually we are going to pay attention about transmitter modules, because this is already a module. You have been learning about how you can define maybe FM transmitter, AM transmitter, PM transmitter. Those are the analog transmitter we call them. But for this particular, it's a digital transmitter. And there are some digital parts that's why it's efficient actually transmitting information over the short distance. So if that's the case, I have some physical students. Let me just appreciate them and let us go into our interesting moments. How are you, students? Yeah. Are you ready for Workshop 7? Wonderful. I'm happy to hear that. So before we start our today's concept, then let us do the quick review of Workshop 60. So in Workshop 60, actually we've been discussing about HT12A encoder, it means that encoder, 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 encoder IC, or integrated circuit. And then we say that this is very interesting because we said itself that it has 18 pins in case of the dual input inline package. And also, when we discuss about this encoder, we discuss about features. What are the features? We discuss about the number of features of 40 of HT12E encoder. But also, we discuss about working principle. What the working principle? Working principle of HT12E encoder IC. Again, we discuss about, I told you how do you use what HT12E encoder IC, just to implement the short distance wireless communication. Short distance wireless communication. And then in those stages, finally, we do overall schematic logical circuit diagram of actual HT12. Simply, it means that of the pole down resistor network. And then we had HT12A encoder. Then we had DC power supply. And also we had just the RF transmitter as the output, so connects the output to thing. So in case you've missed a lot of information about that interesting, very important and powerful encoder or digital encoder, because we have we don't have analog encoders actually. We can have some analog circuits that working as encoder, but they are not performing well compared to the digital encoder. So today, let us pay attention about this type of watching. So we call it 433 megahertz, or sometimes also it can propagate information with a frequency of 315 megahertz. RF transmitter module. Class A 433 megahertz or 315 megahertz RF transmitter module. No. 1, 2, 3. Let us go. Again. Hey! Start again. What the difference between module and something which you don't call it a module? What the means of module in electronics? So I showed you, I think that I showed you those transmitter modules and receiver modules. So let us start this concept by, first of all, learning what is it and how does it work. So we have this question. What is 433 megahertz? Megahertz or 315 megahertz RF transmitter module. So simply say that so the 433 megahertz or 315 megahertz transmitter transmitter module. Say that is the short distance RF or radio frequency RF transmitter that receives the coded information from the digital encoder, that to say HT12E encoder. I see. And the modulate it with carrier signal to produce the modulated signal. Produce the modulated signal for wireless propagation. Wireless propagation. Barak, what are you doing? Huh? Nothing. Sure. Did you take a photo of it? Huh? Where is it? Sure, Abdul. Dennis, did you take a photo of it? No. Okay, again, class A, 433 megahertz or 315 megahertz RF transmitter module. A? Are you serious? Dixon Marcha and the happiness, God bless. Are you serious? So say 433 megahertz, 315 megahertz RF transmitter module. As a telecommunication engineering student, what does 433 megahertz or 315 megahertz represent? What information do you get? First of all, what information do you get from your fundamental skills of telecommunication? Who can tell us? Raise up your hand. You want to try. What information do you get as a telecommunication engineering student when you hear 433 megahertz and 315 megahertz? You can get a lot of information. What are the fundamental information that you might get as telecommunication engineering students, even if you don't know other details, but you just see the frequencies which have been mentioned? So who can tell us? Because I want to involve you in this class. Coded information from the digital encoder, such as that ones, and modulate it with carrier signal. Yes, to produce the modulated signal for the wireless propagation. Budala? Yes. Just tell us, what information do you get?
The information I get is
megahertz. So Bundala said that one of the piece of information that you might get from here, but okay, before just Bundala, let me just explain the definitions and then we go quickly about the questions that I asked you. So the 433 megahertz or 350 megahertz transmitter module is a short distance RF transmitter that receives the coded information. Say coded information. Say coded information. So when we say about coded information, it is encrypted information. So information with particular address. So it's received the encoded information from the digital encoder, such as HT12A encoder, I introduced circuit, and modulate it. Once you receive it, modulate it with a carrier signal to produce the modulated signal for the wireless OT propagation. So simply, it just receives, and once it's received the coded information, which is actually called information signal, it modulates. It superimposes OT, that information signal, coded information, into the carrier signal. And then information signal plus carrier signal, we get modulated signal. And once we get that modulated signal, also these RF transmitter modules, it has a responsibility to propagate those information into the space. Are we together? So from this definition, you can just understand the principal functions or just see the fundamental functions of this RF transmitter module, right? Then the question is, why or what the meanings of 433 megahertz? So Bundala, or in case that you say 315 megahertz. So Bundala say one of the piece information of the information that he might get from this information, this is, we call it frequency. It's a frequency of what? Frequency of carrier signal that can be produced by this radio frequency transmitter module. Okay? And that means that Bundala's response, it's true. We used to name transmitters and receivers according to the carrier frequency or frequency of the carrier signal. For instance, you say that your mobile phone, for instance, ask your neighbor, what the frequency of your mobile phone? Just ask your neighbor, what the frequency of your, what the frequency of your mobile phone transceiver? What the frequency? You used to hear 2G, 3G, right? So your mobile phone is which frequency? Ask your neighbor, because possibly he or she does not know. Tell us. 4G. And you? 3G. Christina? That's what he told you. What's your neighbor's name? Geoffrey. And Christina's phone? 4G. Can she show you? How can you verify? Okay, if your neighbor told you that it's 4G or 5G or 3G, ask him or her to verify. To verify to you, because maybe, for instance, what the frequency of your neighbor's mobile phone? Or he didn't reply? He didn't reply. And you, did you reply his question? No. So you are silent. Why? Young and Simba, or it just happened? So you are speaking different frequencies. Zuena? Tell us. Who is your neighbor? Boniface or Joseph? Pastor. What? So what did Joseph told you? And Joseph paying attention upon you. Waiting you to lie. So what's your neighbor's mobile phone frequency? He's still searching. And yours? You don't know. Why? Where is your Soswado? She's in the bag. So what is the frequency? You don't know. It's not there. If there's no frequency, you cannot communicate. You're just taking, then how about your discussion? Precious, now, are you looking the frequency or you are just checking the message? Okay. So in case of the mobile phone, most of the mobile phones nowadays, we have 3G mobile phone, we have 4G mobile phone, and also in some of the, especially Europeans in the United States, they have also 5G, real 5G, not just like LTE, but real 5G. So whenever you hear about 3G, it means 3 gigahertz, right? Especially features mobile phone, all the features mobile phone are 3G. When I say featured mobile phones, those are the phones that we call in Tanzania Kiswaswado. Those are the 3 gigahertz because that is the 3rd generation. And then we have 4G. So most of us who are in this class, we have mobile phones that operate in 4G. Okay? So 4G and also you have 5G. But remember the world is heading to 6G. So 6G or 3G, when you hear about 3G, that means that 3 gigahertz. And whenever you hear that, now Zantel, we are going forward for 4G, 4 gigahertz. That is 4 gigahertz. And also you have 5 gigahertz. For instance, Tigo, they say that, okay, now we have some chips that can support the 5 gigahertz communication. So this is, all of these frequencies used in cellular network, we call them, these are the frequencies of carrier signal. Say carrier signal. So whenever you hear a frequency of the transmitter, because your mobile phone is transceiver, it can transmit it and also it can receive. So actually we mean that these are the frequencies for the carrier signal and are not frequencies for the information signal. Are we together? Then another piece of information, what do you get when you hear 433 megahertz or 350 megahertz? Who can tell us? What another important piece of information you might get as telecommunication engineering student? Carolina? Adam T? Tell us. So now we are passing first of all of them. Adam T? We are waiting you. Nura, tell us what another piece of information you might get from there. Joseph Benjamin, tell us. Sure. Just see the carrier frequency. Now. Our friend there, tell us. No information. Abdul Majid. Sita, tell us. Tell us. You are feeling headache. You're asking a student. Shedrack, tell us. Tell us. Oh, Rasa, oh you. It's you now. Pardon? Mesau. Hawa, tell us. Hawa, tell us. Nema, tell us. Shukuru, who is doing something? Shukuru, tell us. Pardon? Digna? Angelina? Okay, so Shukuru said Angelina try. Tell us. Tell us, what do you think? Adamu? It is VHF. VHF is the abbreviations of what? Very high frequency. What are the boundaries of very high frequency? You forgot. Okay, very good. So, 433 megahertz, Adam said that 433 megahertz or 350 megahertz, this also gives information that the bandwidth of communication is V, very high frequency. Very high frequency. Very high frequency, not very high frequency. It's a ultra high frequency. Why? We say that from 30 to 300 kilohertz, this is, we call it in telecommunication low frequency. Okay? Then from 300 kilohertz to 3 megahertz, this we call it medium frequency. Ha, ha, ha. That is, and then from 3 megahertz, Johan, what the long term of MF? Medium frequency, very good. However, that we are from somewhere. Then from 3 megahertz to 30 megahertz is what? High frequency. Then from 30 megahertz to 300 megahertz, this is VHF, very high frequency. Then from 300 megahertz to 3 gigahertz, this is ultra high frequency. Then from 3 gigahertz to 30 gigahertz, this is what we call super high frequency. So we have some radars that are operating within this frequency, but those we call them low range radars. But most of the radars operating within this frequency band. So when you talk about 433 megahertz, where is it? These are the 60 bands. This we call the radio spectrum. Write it down. Radio spectrum, if you have forgotten, it's better to remember. So the important concept, just remember 30 kilohertz. Say 30 kilohertz. For those who cannot claim like myself, I can claim those ranges, really. Unless maybe I mention several times, so I use it, then I can claim one of them, or I can remember one of them, but within a short time. Yeah. So for instance, for myself, I used to remember, just I remember 30 kilohertz, and I know the last one is 30 gigahertz. And I know that I expect to have 640 bandwidth. So this is low frequency. Medium frequency, say medium frequency. So say low frequency. Say low frequency. Medium frequency. High frequency. Very high frequency. Ultra high frequency. And this one is super high frequency. So from these spectrums, you can analyze 433 megahertz or 350 megahertz. It's within which radio spectrum. So this spectrums is used specifically for what? For radar. Say radar. Radar communication. But this one is usually for what? For short distance and long distance. For instance, where is your 4G? 4G for your mobile phone. Because, you know, whenever you learn information, you have to relate to something that you are familiar. Precious, your mobile phones is 4G, right? So your mobile phones uses what? LOF, MF, HF? What the long term? This is the long term. This is called the low frequency. Say low frequency. Say low frequency. This one, MF, Joanne has mentioned is medium medium frequency. Then this one, it is high frequency. Precious is conducting a demonstration class to her neighbor. VHF, this is very, say very high. Say very high frequency. Very high frequency. This one is ultra high frequency. Ultra high frequency. Say ultra high frequency. Say ultra high frequency. This one is super high frequency. You know something super? Ask your neighbor, are you super? Ask your neighbor, are you super in electronics engineering? That is a hard question. Because your neighbor might say yes, but even he or she might experience challenges on just designing an audio frequency amplifier. Then, from there, the truth is actually being reversed. Okay, so this we use often in radar communication. This one we use, So I ask you, where is your 4G? Gertrude, where is your 4G now? Your mobile phones, where is your... So what the frequency of your mobile phones? What the frequency band? Gertrude, tell us, because you have been checking your mobile phone. And my radar has detected you. A super high frequency. For those mobile phones, how many of students have 3G mobile phone? All these Osados. All these Osados are 3G. So what are they operating frequency? 3G. Which one? What the band is? Super high frequency. 3G. Super high frequency. Naughty, UHF. You have a question? Ask it. Can you speak loudly? Extremely high frequency is similar to super high frequency. So sometimes called it extremely high frequency, or you call it super high frequency. So our mobile phones operate with what? UHF or SHF? So even our mobile phones operate in SHF. Aha! Fatuma Makame is at entrance door. Wonderful. You're welcome. Then for this one, 30 megahertz up to 3 megahertz. Tell us one of the telecommunication devices that operate within that frequency, bandwidth, or spectrum. 30 megahertz up to 300 megahertz. There is a very important telecommunication instrument that you are using often. Operate within that frequency. Fatuma, tell us one of the telecommunication devices operating within 30 megahertz up to 300 megahertz. Dennis, tell us one of the telecommunication device that operates within 30 megahertz to 300 megahertz, which is called the VHF. Some laptops. Okay. Kankesha? That question is new for you. FM radio. Example for FM radio operates within that frequency bandwidth. Wasafi. And what the frequency of Wasafi FM? You see, the response of the question was very simple for the teenagers. Because you always listen Wasafi, you always listen clouds. But you never think about the frequency. You just think about the message. For instance, for clouds, I think that from Monday to Friday, they used to have just a radio station that's called the Jahazi. And then the radio reporter was just Gardner G. Abbas, who has passed away. So you know it because you listen it in most of the Daladalas, but you don't bother about the frequency. What the frequency of Wasafi? I think that you are Googling. You are Googling. Or maybe you are tuning it. What the frequency of Wasafi FM? So Dixon Marcher said that the frequency of Wasafi is 87.9. This isn't it? This isn't much, 88. 0.9. Right? Shukuru, tell us another listener of Wasafi. 94. That's the goodness of my class. Whenever you ask a question, 94.25 megahertz. Whenever you ask a question which have a single response, for my students will get various responses. That is Arusha. Which one? AAA or Sakina? Sakina FM. The frequency. Okay. So the broadcasting frequency are in Arusha. And the other ones, for instance, yourself, which frequency do you know? FM frequency? None of them. None of them. I could guess. Sonia? Anyway, so all the radio receivers operating within VHF. Say VHF. Say VHF. Very high frequency. But also we have a number of navigation aids operating within that frequency. For instance, aviation radio communication operates 118 megahertz. So 180 megahertz means within what? VHF. So that radio spectrum is important. It's practical more than what we think. So how about the high HF? HF. Mention the telecommunication instruments that are operating within the HF. Precious wants to try. Mention. Are you looking them on Google? Can I help you to keep the phone? Class. The response for these questions is simple. Are you using digital oscilloscope? So what operating frequency for the digital oscilloscope that you have? We have discussed it. We have mentioned when we have been discussing about YOTI, YD, bandy, WOTI, communication, amplifier. You remember that? And else Sierra Oro mentioned the frequency of our digital oscilloscope, which is YOTI. Edison, what the frequency of our digital oscilloscope? Edison is not in the class. 10 gigahertz. 10 gigahertz? No, 10 megahertz, sorry, 10 megahertz. So 10 megahertz is within what? HE. How about the MF and LF? So expect it that most of telecommunication transceivers, you are going to learn from this first year to your final or to your last year, will be operating in either or in it means that within one of the frequency boundaries in the radio spectrum. So whenever you encounter one of them, so you have to challenge yourself. Is this VHF or LOF or HF? Or what is it? Or MF, what is it? Right? But remember that the lower the frequency, the longer the distance. The higher the frequency, the what? So for instance, if you have a transmitter operating within 3 kilohertz and a transmitter operating within 30 gigahertz, which one will cover the long distance? My students, we taught you this concept in physics, the first topic of physics form 4. We taught you that velocity is equal to wavelength times frequency, right? Then we taught you that if you're looking for frequency, this is equal to velocity over wavelength. Whenever you talk about radio frequency, we mean that this is light. So the speed of light is 3 exponent 8 meter per second. So speed of light over what? Wavelength. So frequency always is inversely proportional to what? And when we talk about wavelengths, this is the distance covered. Because we do the waveform And then we say that this is a complete section. What is the wavelength? Wavelength is the distance between two successful crest or trough. Okay? So the transmitter operating with the frequency of 30 kilohertz, when you just consider the issue of frequency and wavelength, ignore about some other factors because power is important, gain of the antenna is important. There's a number of factors, right? Noises within the space. So let us just forget about some other factors. You have a transmitter operating, it means using the carrier signal of 30 kilohertz, and another transmitter that using the carrier signal of 30 gigahertz. Which one will transmit the information within the long distance? Which one? 30 kilohertz. Why? Why 30 kilohertz? Keep it. That's the case. Precious want to give me a case of buying what? A display. Sir, hey, you destroyed my display. You know me who I am. Okay, so when you consider just the matter of frequency and wavelengths, this one will be cover. We call it long-range transmitters. And this one we call them short-range transmitters. But these are low-power transmitter, if you use this transmitter. But this is high-power transmitter. Okay? So remember that each factor affects, and that's why that whenever we are designing or establishing the communication network, we have to take consideration different parameters. We don't just say that, we need just a transmitter of 3 megahertz. No. You can have a transmitter of 3 megahertz, yes. Theoretically, it can cover long distance, but maybe there's a lot of barriers. For example, just the wind directions, the opposite, the directions of that propagation. So you can find that it's not fit, or it doesn't fit. Are we together? Are we together, class? So for this case, we say that the input of 433 megahertz or 315 megahertz is binary coded what? Information. Binary coded what? Information. Then the output of 433 megahertz, this is RF transmitter, TXC, megahertz RF transmitter is what? Modulated signal. Modulated signal. Then we say that the carrier signal generated by the RF oscillator is either 315 megahertz or 433 megahertz. Angelina? What are you doing? You are helping Shukuru? What the frequency of the digital signal of this coded information? What will be the frequency? This is the frequency. This is the frequency of the carrier signal, right? But to get the modulated signal, because you say that modulated signal, we say that we have to take your binary coded plus what? Plus 433 megahertz or 315 megahertz carrier signal. So what the frequency of binary coded information or binary coded data. What the frequency? Because you use learn digital signal. Have you ever think about its frequency? General block diagram of 433 megahertz or 315 megahertz RF transmitter. The first block. How about the first block? How about the first block? How what the first block? How what the first block? Eh? Speak loud. What the first block? How? Very good. DC power supply unit. Fatuma, what the second block? Fatuma mwenye nkuu. Fatu. Shukuru, what they say the block? Engineer Shukuru, engineering student Shukuru. RF oscillator, very good. RF oscillator. Baraka? Baraka? Tell us the first block before you go out. What the name of the first block before you go out? Tell us the name. Just come before you go out. You sure? The name of the first block. Pardon? HT12E. We are not discussing about HT12E. HT12E, it's something else. And the 433 megahertz RF transmitter module is something else. HT12E, it's an integrated circuit. It's black in color. And for the RF, I think that I show you the RF transmitter. Yeah. So the first block in digital electronics, we call it ASK modulator. ASK modulator. Angelina, can you tell us the names of the 50 block? Output. Output of what? So you say electromagnetic unit. That is Shukuru at work. Jacob, tell us the next block. Output. Are you sure? No. Do you think that RF transmitted has output? It has just output in another form. So you have the C power supply unit. Then you have input coded So you see now, Joshua? So in case you want to draw the HT12E, it will be on this side. Right? Huh? Because HT12E encoder, it's a one has to code the information and deliver the inputs to this one. Here we have RF, so for this case it will be 433 megahertz or 315 megahertz RF oscillator. Then the RF oscillator send the information to ASK modulator unit. So this is the general block diagrams of 433 megahertz, 433 megahertz or 315 megahertz. Receive it and then give it back to me. Just receive there, there's no problem. No, the part which is actually used to switch. That at this time, let us propagate or provide a carrier signal of 315 megahertz. So it means that it depends. It means it can work with a receiver that receives 315 megahertz and receiver that can receive 433 megahertz. So it means that 315 megahertz is low frequency. 433 megahertz is high frequency. Amplifier? No. It's not important. It's not there. The amplifier will find in the receiver part. FSK. No, that is amplitude shifting key. In digital modulators, we have different types of digital modulators. That is amplitude shifting key corresponds to AM or amplitude modulator. Okay, so this is the general block diagram of the 433 megahertz or 315 megahertz RF transmitter module. So stop writing, stop drawing. Listen and look. This one, we call it 433 megahertz and 315 megahertz. Why? Because the low frequency for this one is 315 megahertz. And also the high frequency is 433 megahertz. That's the meaning. Okay? Okay? So even its receiver will also have the low range or the low frequency of 315 megahertz and 433 megahertz. Then this range of frequency that whether the transmitter to propagate maybe the lower frequency or the medium frequency or the highest frequency. This depends on the OT, on the power. Depends on the power. Ruben, you are not always allowed to sit there. That's the place for the Benjamin Joseph. And I've been seeing you that you are very interested with Mwendokasi, which you don't own anyone, rather than making a follow-up. And on the window, you have something very important. So every time you want to sit. Okay. So listen. Hello. Shukuru, I told you once you finish your conversation, you give me to help you. Joan, would you like to give me yours? No, eh? No. Joan say no. She's disciplined. Okay, so stop rating. So this is the C power supply unit. For this case, in case of the actual RF transmitter module, we are going to have 2 pins. One pin is written VCC, the other one is written ground. To pretend that these are the pins where we supply power. And then we have input units or coded bits. This one, in the physical one, we call it data pin. Dixon Macha, come back. Dixon Macha, come here, please. This is data pin. So this is the point where we supply what? The input. Then, at this point, we have RF oscillator. Sit there for a while, then we'll go out. Sit, listen the information first, and then you go out. Where is your capello? So this is actual RF oscillator. Its main responsibility or its main function is actual to produce what? The carrier signal, right? And produce the carrier signal within these frequency bandwidths. After that, the information signal or the coded bits and the carrier signal will be fed into the amplitude shifting key modulator unit. This is a one type of what? ASK. Say ASK. Say ASK. Say ASK loudly. So amplitude shifting key. This is digital modulator. Say digital modulator. Up to this time, you have learned about analog modulators, which you call this amplitude modulator. That's the analog modulator. We have also frequency modulator. We call it in short FM. Okay? We have also phase modulator. We call it PM. Those are the three types, main types of 40 amplitude or 40 of analog modulator. In case of digital modulators, we have so many types of digital modulator. But one of them is called the amplitude shifting key modulator. We have also frequency shifting key modulator. We have also binary shifting key modulator. We have a number of them. So we have quadrature, or we call them, we have 4-QAM modulator. We have 8-QAM modulator. It means quadrature amplitude modulator. Because we have 4-QAM. So 4-QAM, say 4-QAM. We have 8-QAM. All of these are modulator. Say 8-QAM. Say 8-QAM. I'm just introducing you. You'll cover them in the next module. Then you have 16-QAM. Say 16-QAM. Then you have 32-QAM. 32-QAM. And then you have 64-QAM. So you see that in case of digital modulators, you have a number of them. So you cannot finish them. Right? So amplitude shifting key modulator. Say it again. Amplitude shifting key modulator. So this modulator is actually going to change the amplitude of the information signal. This corresponding to amplitude modulator, which is analog modulator. It corresponds to AM modulator. Are we together? So its main responsibility is actual to change the amplitude or to shift it. To shift the amplitude of the coded information. After that, we have that modulated signal, which is actual as where the information signal coded information is superimposed within the carrier signal, and then it will be sent to the electromagnetic unit, and after that it will be sent to the transmitting antenna. Say transmitting antenna. Say transmitting antenna. So that's all, and that's how that general block diagrams work. So let us continue with some important information that we need. There's a lot of things actually have been hidden in this RF transmitter module, but we don't have time to discuss all of them, so I'll be trying my level best to give you important information that we need actually to interface this RF transmitter with with just your encoder or HC12E encoder. One of the important information with this RF transmitter is this one that we call them the input voltage. So when we talk about input voltage, the input voltage that should be supplied at data pin. Oh, but I think that's better to draw the physical appearance first. So the physical appearance of 40 of 433 megahertz, 315 megahertz RF transmitter module. So I've showed the physical appearance of it. Then this one we have pin number 1, pin number 2, pin number 2, pin number 3. So the first one, so this is data pin, and this one is VCC, and this one is what? Ground. So also we have an antenna. In most cases we use helix antenna. Say helix antenna. Say helix antenna. So this is an antenna. You may use a wire. You can use as a helix antenna. And sometimes the external antenna, it has built-in antenna, or you call it PCB antenna. But sometimes you can have, and you can extend that antenna in order to increase the distance. Okay, the distance of 40 of transmission. So within it, you'll find oscillator, the modulator, the ASK modulator. So this is the input pin. These are the power pins. And then all other electronics components are within. But you can see, you'll see two inductors. Okay, two inductors. There is one inductor that we call it L1, the other one is called L2. But also the 433 megahertz RF oscillator, it's a one that which is white. So you can call it this iron material. So this one, that's we call it RF40 oscillator. Kankesha, where is the RF oscillator? Kankesha was not in the class. So the round one, or the round components is RF40 OC oscillator. Its frequency is 433 megahertz up to 315 megahertz. So some important information. The first one, we say that according to its data sheet, the input voltage, when you say input voltage, is the voltage supplied to the data pin. Say data pin. This should be 5 volts. But again, we need to know what operating power. So we say that the range of operating power supply for this is what? The range of operating power supply is 2.4 volts to 12, if I'm not mistaken. Is this Interdam? Can you check? I think that told you that I'm very weak in cramming. Is this the range? 2.4? Okay, 2.4 volts to 12 volts. But typical voltage or operating voltage, typical is 5 volts. Then another important information that you may ask is, what its coverage distance? How long? For how long? For how long this RF transmitter can transmit the information over the space? So you say that in open space, the 133 megahertz or 315 megahertz RF transmitter can propagate the signal over 100 meters. So it can propagate the signal from one side of the pitch or football ground pitch to the other side, but in open space. But when there's a number of obstacles, the distance covered might be less than 50 meters. Okay? So whenever you want to design a wireless communication system of 100 in open space, 100 meter in open space, or 50 meter in, even if in non-open space, then you may use this RF transmitter for that purpose. So make sure to download the data sheet. Download the data sheet. So is that the case now? We need to know now the overall schematic circuit diagrams with this RF, or just it means that in the previous schematic circuit diagrams of HT12 encoder, in RF now, or where that you have RF transmitter, you have to use this component. So this one, you have to connect it to power. Let's say that this is C, which is 5 volts, if you do remember. Then the other pin, you have to connect the common ground, right? And then these pins, you have to connect it to D out. So from there, you have your overall schematic circuit diagram of your radio frequency transmitter. Class, are we together? Are we together? We are not together. Stop writing, please. Shukuru, where is your exercise book? Shukuru today has a number of problems. He doesn't have even the exercise book. Huh? That one. Stop writing. Do you remember that we discussed the schematic circuit diagram where we have the C power supply unit for the HT12, and also here we use the pull down resistor network. You remember that? Eh? And then here we had the HT12E encoder. You remember that? Whereby 5 address pins are connected to VCC and 3 address pins connected to ground, and also the 9 pins is connected to the ground. Right? And then, okay. So on this side, this is the side that where we had the pull up down resistor network number 1 and pull down resistor number 2. Then we connect them into AD8, if you do remember, and the AD11. You remember? Eh? Transmission emission pin, we connect to the ground. Oscillator pin 1 and oscillator pin 2, we connected to the resistor with resistance of 40. Resistor with resistance of 40, Joshua. With resistance of 40, Joshua. Eh? Morning. Resist 100. Yes. Hey. So, in oscillator 1, according to Joshua, who was in the class, we connected the resistor with resistance of 100 ohm. Mungu ibariki Afrika, wabariki viongozi wake, hekima, umoja na amani. Hizi ni ngao zetu Afrika na watu wake. Ibariki Afrika, ibariki Afrika, tubariki watoto wa Afrika.